Alright, hi. Welcome to the last video we're going to do on reviewing linear functions. Today is going to be about writing equations. So by the end you should be able to write the equation of a linear function in what's called point-slope form. And you'll be given either a point that's on the line and the slope of that line, or 2 points on the line. In here I'm going to concentrate on what to do if there are 2 points on the line, because the first thing you have to do is calculate the slope. So if you're given a point and the slope, well, you just ignore, you're starting already halfway through the second case. So it's just easier. Alright, so let's say we have 2 points. We'll call them point 1 with coordinates x1, y1, and point 2 with coordinates x2, y2. I probably mentioned this in class. I don't remember if I mentioned it in an earlier video. Anytime you see a number or letter or anything written in subscript, it's like kind of like an exponent, except it's down low instead of up high. That's just a descriptor. So here, this x1, that 1 means that it is the x-coordinate from the first point. This is the x-coordinate from the second point. You'll see this a lot throughout the year, and you'll see it in like your chemistry classes, your physics classes, any sort of science like that, where you might need to use x or m or something several times, but you want them to, but they're different, so you use a little descriptor, x1, x2. Later on in the year we'll see with matrices, maybe if we get to it, we use a lot, and it'll be a1, a2, a3. Rather than using every letter in the alphabet, we just call them all a, and then use a little number to tell you which one is which. Alrighty, so we have these 2 points. I'm just going to plot them somewhere on a coordinate grid, because what we'll need to look at is we need the rate of change between the points. So here I kind of graphed them, and yeah, they have specific numbers, and we can look at what the slope would be here. But remember, these are just supposed to be kind of generally thrown out there. They could be anywhere. So what we need to do is figure out how fast this line is going up, or it could be going down, really. If I would have put this down here somewhere. But we need to know how fast it's changing versus how fast it's going over, which is your slope, rate of change. We've been calculating that now for a few days in review. Remember, that's the formula you use. Use the y-coordinate from the second point minus the y-coordinate from the first point. And then on the bottom of this fraction, you put the x-coordinate from the second point minus the x-coordinate from the first point. You have to be sure, again, I know I reminded you before, make sure that you put y minus y on top, x minus x on the bottom. Don't flip them over, don't switch them around. Make sure you have y and y, x and x. Alright, so that's going to give us the slope, which means we'll know what that is, but we don't know where it might cross. Like here, this line, what we now have is this blue line, because we know the rate of change is m, and we know this much of the equation, y equals mx, but we don't know in particular where it crosses the y-axis. If we did, it'd be easy, we just add or subtract whatever on the end. I know this red line looks like it's going through 2, but remember, I just threw the 2 points on there wherever at random, just so we had an idea of what we're looking at. Finding this y-intercept is sometimes very difficult. So what we're going to do is we're going to think back to kind of the beginning of the year in geometry, when you did translations. We're going to take this blue line, specifically where it crosses here at the origin, and we're going to move it to one of the 2 points we were given in the original problem. So we're going to translate this over to y1. Works the same if we go over to the second point. We're going to move it over. Now, I don't remember if you covered it. I know my college prep geometry did, though who knows if anybody remembers, because it's been a year now since we did it. But in order to move that point, what you're going to do is subtract the coordinates of one of our points from the variables in the equation. So this blue line becomes y minus y1 equals the slope times the quantity x minus the x coordinate. X and y are still the x and y from the line equation. M is our slope, and these are the coordinates of our first point. You could use either point you want, it'll come out the same, but we're just using the first one here, just keep everything kind of simple and on the same page. So now I'm going to switch over to an example of this, maybe. There we go. Get this to record. Alright, the example. Write the equation for the linear function that passes through the points -3, -5, and 4, 9. First thing we need is our rate of change, which is the y from the second point minus the y from the first point. So it's minus a -5. Messed up here. There we go. And then on the bottom we have the second x minus the first x. So 9 minus -5 is 9. Plus 5. 4 minus -3 is 4 plus 3. 14/7, which reduces to 2. So our slope is 2, which means right now we have y equals 2x. Now at this point, this is equivalent to back on the PowerPoint presentation, the blue line that was going through 0, 0. So we know the rate of change, we have a parallel line, now we just need to move it so it goes through the first point. And I'm going to use the first point, -3, -5. So y minus -5. And go ahead and set it up like that, even if you think you know, alright, y minus a -5 is going to be the same as y plus 5 on the next step. Go ahead and take the time and set it up with that minus the negative, just so you don't make any mistakes. Slope is 2, and from the x I'm going to subtract the x coordinate of -3. That's all that fancy formula from the PowerPoint is doing. You're subtracting the coordinates so that way the line moves. So that'll be x plus 3. And from here we just need to get y by itself. So a little distributive property. Subtract the 5 to the other side. 2x plus 1. There's the equation of the line. Alright, so that was really quick going through that. But the process is pretty straightforward. Again, it should be reviewed, so it should be clicking on some things you did back in Algebra 1. find your slope if you need to, if you're given 2 points. Get your basic equation there, and then move it by subtracting the coordinates to whatever point you need it to get to, and simplify it. And that is that. There won't be I don't think there's going to be a video for the next couple sections. We're going to concentrate on doing a lot of that stuff in class. I might post a couple of the examples we do, but there won't be like an instructional video like this. All right, so thank you.